Hey James, how are you?
Nick, great to see you. I'm doing well.
God, I'm so happy to talk to you. I know it's taken us a while to kind of schedule this, but I'm glad we're finally on the platform. So, how are things in jolly old London?
Well, it's summer is approaching. The sun's out. It's finally stopped raining. It's been raining here for what feels like months, but
Ah,
the weather's great. Summer's starting to approach, so things are great. Thank you for asking, Nick.
oh, awesome. Yeah, actually, we might come back to London this year. It's we're pretty close to that. I'll let you know. When if it all kind of clicks. It comes together.
Good.
But
Yeah, it'd be great to see you. Yeah, and
oh my God,
exciting
oh,
times
thank
for
you.
Ono, right? With the
Uh,
AI conference coming up in Dallas.
I tell you, James, it's really been so much fun, working with the team and we learned a lot in 2023. We last time we were in Dallas, Doug Comer gave a talk on kind of really just kind of an academic perspective about AI. That was really well, um, attended, and also it just a lot of people were excited about it. Obviously, we're living in the Chat GPT moment, and then in the fall, we had Andy Brown and Phil T do a keynote on the second day that really talked about their perspective on the impact of AI in the enterprise marketplace. Not in the kind of consumer space and the whole government space and regulation and stuff like that, but its impact. That was over the top, and so we asked them to do a track, and they said, yeah, no, I'd love to. And so after our first meeting, we realized this isn't a track. This is just like totally changing everything we're doing. And so
Yeah.
that's why we're calling it the AI Networking Summit. We'll probably like in the fall timeframe, we'll actually start to really put the Onug name, down on the bottom, so it'll be produced by Onug and it's still our community, but that's really going to be the focus, moving
And a
forward. But
and a very prescient talk, I think, Nick, because we're starting to see enterprises really look at how they can reduce their operating costs to start to shift dollars towards investing in AI in their business, and the levels of efficiency gain that enterprises are really looking at in terms of the kind of administrative operational type functions are very significant. And
mm,
I think AI and investments in AI, particularly generative, are going to be the
yeah.
kind of the next wave of IT spending. It's going to be the IT story for the next half decade.
Yeah, I'm with you, and I want to dive really deep into this, in this discussion. But first, I want to make sure everybody knows you. Like I know you, James. Like I've known you for a couple of years. I haven't known you for like decades, but I've known you for a couple of years. We got introduced by Ernest Leffner, who used to work, for you, and so I want to make sure everybody knows who you are. You have this really wonderful career journey and path. So could you share a little bit about it before we start?
Sure.
Because
Yeah.
like
I
once they hear that, the weight of your words are going to be enormous. So go for
So who doesn't like talking about themselves, Nick? So I was brought up in the UK. I was born in what is of course the most beautiful town in England, if not the world, Stamford in Lincolnshire. And
it.
I actually started my career. We were just talking about this before you kind of pressed the go live button. I actually started my career as a sound engineer before I went to university, putting on kind of very large concerts, like rigging sound stages and so on. Then I went to university.
Wow.
I was studying economics at Newcastle up in the north of England. And I started out my career actually as a programmer working for my dad's software company. And
Ah,
so he was a kind of early adopter of Unix. So I was kind of a Unix System 5 Release 4 kind of, I guess you call it a systems admin now or something. But
yeah. Uh,
and so I kind of cut my teeth on Perl and Sed and Awk and all those kind of tools that I'm not sure anybody really uses anymore, and Cobol, funnily enough. Um,
hmm.
and then we started to invest in what was called a fourth generation language, 4GL at the time, called Uniface 4GL. I don't know if Zoom is still going now.
Mm.
And there was one other large corporation that was using Uniface 4GL that was hiring, which was Walt Disney Pictures. So,
Huh.
I left my dad's firm and I went to work for the Walt Disney Studios for a few years, which was just fabulous fun. What a great company,
Mm.
just great people. I worked for people like Don Clark, Sherry Brown, John Kovas, really inspiring, great leaders. And
Mm.
after a while, I moved on. I went to work for JP Morgan, another great company in network operations in London.
Yeah.
And I spent a lot of time there, kind of having to build our own network management tools. It sounds kind of crazy now because the tools everywhere,
Off
but
the
at the
shelf.
time you
Yeah.
had to build a lot of your own tools. So we built capacity management tools, usage-based billing systems, network monitoring tools, and so on. And after a while, I got outsourced to a company called CSC, Computer Sciences Corporation,
Oh yeah.
now part of DXC. Uh,
Yeah.
and I spent a few years there in kind of outsourcing network services, mostly for banks, and then eventually kind of headed back to banking myself and went to run networks for Credit Suisse back in 2005. I
Mm.
did that job for a while. Moved to Morgan Stanley. I did the sort of similar sort of thing there, networks and procurement and cost savings and those sort of things. And then moved to Bank of America, and that's where I met Ernest, or I met Unique in 2014. And then I left Bank of America about just over a year ago to come join IBM, and I'm in I work for IBM Cloud, and I'm in a role called Cloud Economics. So really looking at the
Uh,
economics of cloud, both as a cloud provider, how we make money, and also how we help to save money for our customers. So it's really interesting and slightly different venture for me because I really felt, I spent most of my time in the enterprise, most of my time running, building and running networks. And I met so many great people from the community and so many great people from Ono. You mentioned Andy Brown earlier. Andy and I were former
uh,
colleagues at Credit Suisse.
mm.
Andy, in fact,
Oh
was a
yeah.
predecessor in my role running networks at Bank of America. He ran networks at Merrill Lynch, which was
Yeah.
acquired by Bank of America. So it's kind of Phil T, an industry legend. So
Mm.
I think it's kind of within the community, we all know each other pretty well. It's just a great bunch of folks. I feel lucky and privileged to have spent my time working with such amazing people, yourself, Ernest, Andy, and so on.
Yeah.
It's just great to be talking to you now, Nick. So here I am. So I'm
Awesome.
I'm 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 at IBM in IBM Cloud, learning about
Yeah,
cloud
well,
and
so,
AI. Well,
what I love about your background is that you started off in coding and software, and that in the kind of earlier part of the kind of computer science kind of development, right? Or the arc of it, and then came into networking, and now we're really coding and software is becoming so important into like the networking infrastructure space as well. So I love that you have both of those backgrounds, and in particular, you have backgrounds, that straddle both the consumer, side of it, and then also the supplier, side of the marketplace, and that's really unique. Really, your backgrounds is pretty. There's a lot of parallels with Andy Brown's, background, as well. So that's probably why you guys just seem so
I
smart.
hesitate to compare myself too closely, Nick, because Andy's just smarter than like anybody else, including me.
He is, I tell you, Andy is amazing. I so enjoy working with him, and when I'm actually talking with him, I've got to think hard, and I've got to like, pay attention, to like every word he's saying, and process it as quick as I can. And I love that. It's kind of a challenge, he's got this really kind of wealth of experience and he can articulate it like really, really well. So,
Yeah.
well, let's see. So, I wanted to like kind of draw upon maybe one experience that you shared, um, and see if that can kind of lead us into like present day. So, when we were in London, I don't know, a couple of years before the pandemic, you gave a presentation around the automation of network infrastructure over at Bank of America. So it was a very large project, that you did. And the results, were, you were hoping for better results. I think that's the way I remember it. If I'm wrong, please correct me. Um, but I think, if you can talk a little bit about that, it would be great because I think that kind of sets the stage for maybe the gaps that were in the industry at that point in time, and maybe how those gaps are now closing. As we start to kind of really move into like AI infrastructure and AI networking. So,
Yeah,
can you talk
sure,
about that?
it's an absolutely kind of fascinating time, Nick. And I look back over the last few years because you kind of, if you look at kind of networking and you compare it to um, almost any other kind of technology in IT and enterprise IT, it's the one that kind of stayed a bit stuck.
Mm,
It's like
yeah.
if you go back to the kind of compute days, certainly when I started out, and I was back in the 90s, I was working for JP Morgan. You had DEC Baxes and
Mm,
AS400s and
yeah.
Stratus
SNA.
and
Mm,
all this kind of all these kind of different flavors. There's VMS and different operating systems and
yeah.
the world eventually kind of converged on Unix-like infrastructures on Linux and predominantly Intel and ARM kind of RISC type
Yeah.
processes. But pretty much if you kind of you're a programmer, you're an SA, you sat in front of a computer screen in the 90s, you had to know that operating system, you had to know those tools.
Mm,
10 years later, you could sit down pretty much in front of any computer in the world and it would kind of look the same, right? And the tools and the programming languages and the interface and everything else was going to be pretty familiar to you. That didn't happen in networks. It was
yeah.
proprietary platforms, proprietary operating systems, proprietary CLI driven, predominantly CLI, command line interface driven
Yeah.
interfaces to networks. And I employed, throughout my kind of career running enterprise networks, you know, hundreds or even thousands of people that were really, really smart, that were really technical, that knew how to build these incredibly complicated systems using all sorts of hieroglyphics that nobody else would understand,
Yeah.
with thousands of lines of code that was mostly manually crafted. That if you transposed a couple of characters, like the most complicated problems could occur. I remember one example, the bank I worked for, I won't name them, where we were um, implementing some new route filters, in India, and somebody transposed a couple of characters in about 5,000 lines of code, and it took
Mm.
out ATM machines kind of across the whole bank in a completely different continent, and
Wow. Small
because
mistake,
it's
big outcome.
BGP. There's a more specific route which just happened to be for the bank's entire retail network that just happened to be a 4G router sitting in a wiring closet somewhere. So
Yeah.
these unintended consequences were really really hard to detect. They're really hard to kind of plan out, and this kind of manual crafting by really, really experienced, smart people that was still incredibly risky and could go wrong. And as you remember, a few years ago when we first started talking about I was this large scale automation program that we were working on, again, as you mentioned with my prior employers,
Yeah.
we put a lot of money into. It's a big project. It was a combination of a managed services deal that was sort of empowered by a joint investment in the automation. So the concept was really, kind of the provider would take away the the operating risk, financial risk for me, and operating risk because we jointly invest in the automation, and they would effectively guarantee the result for me because they were also going to operate the network, and we sort of built in the advantages of this automation we were building. And it was kind of naivete on my behalf, really, because they were really complicated, hard problems that I thought I could solve, that other people much
Yeah.
smarter than me had been trying to solve for a long time and hadn't, which was
Mm.
this heterogeneous environment from a design standpoint, from an equipment standpoint. Networking is a really simple problem at its heart, which is you want to move packets around primarily.
Yeah.
I want to move packets from
Hmm.
one place to another really quickly and in a lossless
Securely.
way,
Yeah.
and secure. And I want to be able to enforce policy. Is this packet
Yeah.
allowed to go there? Is it not allowed to go there? You can see that thing and so on. So it's a really simple problem, but it's really, really hard and really expensive to do well. So I thought, by building, automation, which is predominantly around kind of understanding state, understanding the configuration of the environment, and being able to orchestrate that environment kind of consistently and centrally, I could solve that problem. And the difficulty was there's so much variation in the kind of configuration. There's so much embedded complexity from 10 years ago. Somebody had some application in Australia that needed a particular route setup or something, and it got embedded somewhere in all these in this network underlay. And that guy left the firm and nobody knew it was there anymore. And then you go, upgrade the equipment and something catastrophic breaks and it takes you hours to fix. So what we started to deploy and roll out, which, I guess, what became known as, software-defined networks. But what we mean by that is, kind of network systems that had, centralized controllers. And you're sort of moving away from the initial concept of the internet, I suppose, and distributed network systems that the control plane and the forwarding plane sit on the same piece of equipment. That in the there's no centralized control because there's nothing that can go wrong. If you go back to the ARPA days, they're worried about nuclear war and so on. That device is resilient and will survive. Any kind of catastrophic failure, elsewhere in the system. So we kind of move away from that and said, well, as you move to these controllers in software-defined networks, like software-defined WAN, so I think the first controller-based system we implemented, again, prior employer was a wireless system. One of Conrad, in fact, one of former ONEG
Conrad
alum.
Menezes. Big shout out to Conrad.
Now at HP, I think it was Conrad that did a lot of the development work on that system at the back. And what we found was these kind of incredible gains in efficiency and consistency in our ability to deploy at scale. And I kind of had to take a bit of a step back and think, you know what, it's kind of trying to automate and orchestrate complex legacy systems that have got all this legacy kind of configuration and code embedded in them. It's really hard and really expensive. And in fact, just kind of coding up a specific use case is much more expensive and much harder than actually kind of ripping out that legacy environment and putting something more modern in. So was I disappointed in that project? A little bit. I mean, I think it was still it was a great project to work on. It met its financial goals and so on. But one of the learnings from it was, if we moving to more modern, controller-based networks, software-defined networks, it is the risk-reward trade-off. The risk of when something goes wrong, you go really, really horribly wrong and catastrophically wrong and take your whole data center out, controller failure or something. That has happened in a few places. But the advantages from the standpoint of the cost of operation, the configuration, and so on were very significant. And as we start to move into kind of AI enabling our networks, you've got much more. The data's much more available. You can start to build data lakes. You can start to build up kind of data in a kind of consistent way across your environment, you can start to use AI and machine learning techniques to gain much more insight into what's actually happening in your network. So the whole kind of cost of operation starts coming down.
So let's explore that a little bit. So you mentioned kind of there's the control plane and there's actually the forwarding plane, and both of them have state, information, right? So on the forwarding plane, we have ways in which that state is communicated. Whether that is like S-flow, or SNMP, or proprietary mechanisms or APIs many companies support. There's no consistency in those logs, though, that are communicated. So maybe there's a canonical, way in which the industry can gather, but the industry has been reluctant to do that. But there is data there, and there's a huge amount, of data there. All right, and then on the control plane, that's all the configuration state, information within the infrastructure. Different vendors have different ways to kind of communicate that configuration state. So I think on the 10,000 foot level, I see, okay, great. We do have lots of ways in which we can get data that can be aggregated so that the posture of the infrastructure could be assessed, both in terms of maybe availability and any kind of metric that you want to, attach to it. And even security can be laid onto that as well. So you can have a posture of performance, a posture, of how secure, the infrastructure is. And you can actually do that maybe on a per flow basis, as well. And that can be presented to an application. So an application can then, or the infrastructure and the application, relationship could change, where there could be policy that is going to be directing how this infrastructure will be able to service that application so that the end user gets this really great experience that's dictated all by kind of policy and conformance to regulations and so forth. I think so. I can see that, but it seems like once you dive into it, it's almost like the experience that you had, in trying to make that happen. And I'm a little bit worried that, okay, we're kind of assuming there's going to be some AI pixie dust that's going to be spread all over this, that will solve that. So I'm not sure if you've as you kind of think about this, d- will AI be able to actually solve this problem? So that we can have an infrastructure that we have lots of different, like, whether it's an AI orchestrator or a controller, that can actually view a huge amount of data and then, help in making, decisions, that we'd have to get comfortable with. And then the question there too is that, you mentioned, heterogeneity, or mixed vendor environments. Um, who's to say that everyone's going to adopt the same kind of AI? So there might there could be
Mm-hmm.
various different proprietary AI implementations, and so like and then all right, how do we deal with that? So I love the promise of the world that we're getting into. I'm a little bit concerned about the human behavior, corporate behavior. That is, it's capitalism, and it's try to preserve your market share and to lock in customers, and if that may slow down, I think what we're hoping to like see achieved here. So I don't know. Any thoughts?
Yeah, well, I mean, there's a lot to unpack there, right?
Sorry, there's a lot there. Sorry
So,
about that.
I mean, I don't know. I try and kind of peel things a little bit back a little bit. It's like
Okay.
when you're looking at kind of data and telemetry and it's kind of a starting point for kind of how you make decisions, how you operate networks and so on. Then the first kind of point I guess to make is as we moving out of a pure sort of enterprise environment into a hybrid environment, some of the infrastructure is not going to be controlled by the enterprise anymore. So I guess that was one of the
Hmm.
points you're making about this heterogeneous kind of environments. Is back in the day when you and I probably first started building networks, it was kind of you owned everything. It was you had
All
lease
right. Yeah.
circuits and you had your own data centers and you kind of controlled the edge and everything else. And now it's kind of, well, you maybe own your own data center and the network within the data center. The transport might well be internet based. So you're running kind of VPNs of some description over public networks. Um, and some of that compute capacity is going to be in the cloud in form of platform as a service, infrastructure as a service, software as a service, and so on. So you've got these kind of mixed environments that you're working in where you don't necessarily control everything. And also and this is kind of a key problem, I think, for there's a couple of key problems for kind of network people who traditionally run networks. One is the observation point changes. So in the past, you used to be able to observe, flow across kind of routers and switches. You could put probes and sniffers, and you could span ports and all the rest of it. And you spend a lot of money on buying probes and collecting data. But if you're now encapsulating traffic and encrypting traffic, so even within the data center with protocols like VXLAN and Geneva and so on, then kind of what can you see from a probe that exists at the kind of layer 2? It's I can see some layer 3. I can see some encrypted traffic that's encapsulated in something. So that doesn't tell me a lot. Now, from an operational standpoint, when you've got developers and the folks running applications saying, well, tell me what's going wrong with my application. Tell me why my application isn't performing. You could kind of, well, I can't see anything, guys, right? I can just see some encrypted traffic passing between two endpoints. It looks good to me. It's like the 21st century version of I can ping it from here, right? Which is response back to the developers, right? When you had a problem. So and so in a way you've got to have almost a shift left of network operations from the folks that are providing the infrastructure to the developers themselves, because applications are going to have to signal their requirements into the infrastructure in some way, because they're going to have to tell you have to tell the the internal network or an external network or an internal infrastructure or external infrastructure what they actually need, what I need in terms of security, and what do I need in terms of performance and so on. And it's kind of I know I'm kind of it's a long trail of breadcrumbs, but that's why work such as the policy as code work that ONEG is doing is so important, because we need standardized machine readable ways of encoding policy and setting policy and being able to signal kind of policy requirements to the infrastructure. And so when you start to kind of at least standardize the way in which we describe the environment and the way in which we describe the needs of applications and workloads that are running on our networks. That's the point at which I think it becomes we enable some of these the promise of AI and machine learning and these kind of new ways of working. If you're having to embed policy kind of deeply inside kind of configurations in lots of different types of machine, it becomes really hard. And I think the point you made earlier about if you trace the end-to-end path of some transaction and all the different pieces of equipment that it has to traverse, with firewalls and routers and load balancers and WAFs and everything else, right? You have to encode today. You have to encode that kind of policy all the way through that sort of signal path, and it's really complicated and it's really hard in provisioning new services. As anybody who runs an enterprise network will tell you, it's kind of figuring out how to get two machines to talk to each other across different zones with different security policies associated with them is kind of hard, right?
Yeah. So I think a couple of things I kind of gleaned from that. One, kind of the shift left, and I think you're absolutely right. Like most enterprises own a lot less infrastructure than they used to. And I think the last time we actually did a poll on this is that like 50%, or they basically saying they own like 50% less of what they used to own, like 10 years ago, and that's obviously, and that's increasing. So services, around infrastructure. And then it's
Yeah.
being able to kind of leverage those services and maybe kind of the AI platforms that they embed into those
Yeah.
services.
And how do you know when they're
To
going wrong, right? If you can't instrument them yourself, how do I know if somebody else's infrastructure is is playing up, and that's the cause of some performance degradation or something in my environment? I mean, you know much more. You've got to be able to, we used to talk about this kind of mean time to innocence in network, right? It's like how
uh,
quickly can you prove that the network wasn't the problem of,
yeah.
wasn't causing this problem in terms of application performance? That just got a lot hard. Just got a lot harder, right?
I know, yeah. So the whole observability, AI
Yeah,
observability, becomes like really, really key there. Um, so I think there's that, part of it that will maybe play a component into this. Um, and then, so I'm not sure, like, where do you kind of see kind of hope for that outcome that we were just, talking about, where the infrastructure is able to kind of automate, like almost like, can you have lights out operations, network
yeah,
operations? And that I know we talked to, I think the other key piece that you mentioned is the whole policy as code. And so have the application to be able to signal to the infrastructure what its requirements are, what its overall needs
yeah,
are, and then have that infrastructure, maybe that gets signaled to an AI orchestrator, and that orchestrator then orchestrates, those policies, or orchestrates the infrastructure so that it delivers on those policies, and it monitors that, as well. So,
yeah,
or maybe this is kind of really where, like, we haven't, like in terms of like really product development, if we think about product development in the whole AI networking space, um, like right now, I'm kind of thinking there's like probably three phases of this, and maybe this kind of ties into this discussion, James. Like the first one that we're seeing right now is kind of like the Gen AI products. All right. And these are kind of existing products that have been in the marketplace, but now they have kind of a AI, kind of module or interface, that makes the operations of them a little bit easier, be able to answer questions, associated with them, get support and so forth. And I think that's really useful, and that's helpful. Um, then I think, the next phase, and actually we're going to see this phase like coming up. Actually, at this ONU, we're going to see, I know one company in particular is going to actually deliver an AI firewall. So it's like a rethinking of the firewall from the ground up, and try to do away with ACLs and all the rules and all the toil associated, with all those rules. Um, so I think that's kind of like the second phase. I'm kind of thinking that's a pre-AGI, products, right? So we have kind of GAA products that are everyone is now adding to their products, today. And then I think, there's the beginnings of like kind of, an AGI kind of products themselves. So these are kind of self-contained within that particular product. And then, so that could be kind of a pre-AGI. And then there's kind of the AGI infrastructure. I'm not sure how long that gap is. And that's when you actually have um, learning, communication, synchronization between products that deliver a better, larger effect. So I kind of view that as like full service driving, like with Teslas today. So it's
hmm,
like I've been driving a Tesla for a decade, right? So it's like all of the cars, I've been providing. I know I've been providing video snippets, to Tesla for like the last like at least 6 or 7 years or so, and so large neural net, and now that's kind of delivering a service where the cars can, be pretty much autonomous. It's like, I downloaded the new version of 12.3 this weekend, so I've been using it, and it is remarkably better, but it's still not perfect. But it's like from like, like basically from 2016, it's like night and day. So
yeah.
anyway, so
And look, I
that's what
mean,
I'm kind of thinking.
I think the game changer is when you get the network effect, right? You're driving along in your Tesla, and it's talking to the Tesla in front. They run into a truck or something, right? Right. You don't even have to be within line of sight. Your Tesla should know there's an accident up ahead and put the brakes on or reroute you or something else. So it's when all of these systems start talking to each other and sharing information and on optimizing traffic across the entire system, that's rather than as an individual autonomous system, that's when we're going to see the real benefits, right?
I'm so with you. Like I get a little taste of that today. So for example, like my Tesla will geomark, where there are big potholes. So if I go over
Mm.
that, before I go over that, it'll increase the suspension system, my car. So like, okay, I'm not going to bottom out, when I hit that. And I think, wow, that's like so cool. I love that, kind of automated feature, there. But yeah, for them to be able to kind of communicate to each other so that you can now, like right now, okay, yeah, when there's traffic. If there's traffic, it'll divert you. But like it would also be good to know is like, okay, is there an accident in the left lane or the right lane? And so then it could like okay decide it's going to move over to like to avoid or go into the
Yeah.
the greatest
Or apply
flow
the
of
brakes,
that.
right?
Oh, well, yeah. Well, you think first. Sure. So I think that so going back to like our industry, I'm thinking that we're kind of in the Gen AI phase of products. We're going to start seeing products that have their own kind of embedded AI, and so I think we're going to have whole new categories or existing products like okay AI routers, AI firewalls, AI load balancers, AI PCs, for sure that are coming from AMD and Intel and Broadcom and and others. So we're starting to kind of embed AI into all of these the an applications supply chain, right?
Yeah.
Or dependency map, right?
I
Um,
know, Nick, I wonder, I think like, are we going to see AI solving kind of legacy problems? Are we going to see AI
mm,
reinventing the kind of paradigm? What I mean by that is kind of, hey, somebody comes out with a great kind of Gen AI sort of code generation type application, which will allow you to much more efficiently generate error-free code to certain your existing network systems. Hey, I'm going to be great at writing, Cisco CLI to orchestrate my current environment.
mm,
Or are we going to see? And this is where I think we're going to go. Is we kind of, we'll not abandon the past because we sort of this billions of dollars of an installed base of kind of legacy equipment. But I think the exciting developments in AI are when we will kind of we'll sort of move past that paradigm. And because if you think again, if you go back to what do we do in networks? If I want to build a network today, we have to have all these kind of network architects and network engineers, and they kind of design all these configurations and test it and everything else. Whereas really what I want to say is like, here's my business need. My business need is I want to connect these two places, these two
mm,
systems or multiple systems. I want to set a security policy, and maybe I want to set a kind of a performance policy, and I require certain performance characteristics. So the need is really simple, and and then I need to operate it and monitor it and make sure it's meeting my needs. But and it's a really simple problem that requires lots of money and complexity and talent to solve. So I
wow.
think if I'm looking at network and security from a kind of connectivity standpoint.
Mm,
There's kind of we'll start seeing more ML will become more ubiquitous in monitoring, self-monitoring, self-analyzing, self-correcting kind of networks, predicting network failures, identifying inefficiencies, and proactively maintaining the environment, all those other things. Then I think kind of we'll get more into traffic analysis and prediction, so that the sort of networks will become more adaptive in terms of managing bandwidth and reducing bottlenecks and improving user experience and so on. And I think we see there's. I always think we're going to bottom out on the amount of traffic we put in the network, and we never do this. And people always find new ways of putting huge amounts of bandwidth, right? Like who'd have
yeah.
predicted prior to COVID that we would all be sitting in the next room as each other in the same office on a WebEx or a Zoom chat rather than having a meeting in an actual meeting room. I mean, it's just kind of crazy. everybody uses video. We're using video now to talk to one another, right?
No.
Then
I find meetings, I find meetings without like, Zoom with like, so like 1990s.
Yeah. It's
But
weird.
I'm sorry,
Like
go ahead.
nobody has a conference call anymore. Yeah, but before the
Yeah.
pandemic, I mean,
Oh,
you don't like
thank
I didn't
God.
always turn my video on, right? I mean, so and then
Right.
you look at but then you look at things like these are these kind of link state protocols that we have to for kind of that form the kind of fundamental basis of routing decisions in networks. It's like
Yeah.
you put sort of I have a cost on a particular route, and then is that link up or down, and you have these routing algorithms that figure out how I'm going to send traffic. And as that feels like a kind of a yesterday's paradigm, right? It's
Yeah.
as we bring AI into automating kind of route selection and traffic management and network performance based on real time conditions. This is sort of the promise, not quite there yet, of SD-WAN. I'm going to measure in real time what the performance characteristics of any kind of network path is, and I'll figure out how to best optimize my traffic. And again, I think that leads into kind of these kind of QoS type
Yeah.
enhancements, I guess, where we dynamically, adjusting sort of quality of service based on the network conditions, application requirements, and if we're in a world of constraint, we've got constrained bandwidth or something, it's kind of we would make more intelligent decisions based on how requirements are signaled to the network. And I think you when you mentioned AI enabled firewalls, that's
Yeah.
the kind of really interesting thing move to me, because anybody that's run a large enterprise network where you've got multiple different kind of internal security boundaries, external is kind of almost easier to deny or less established or something, right? But you can have literally hundreds of thousands of internal firewall rules
Yeah.
that are sitting in, right across the infrastructure. It's really hard to keep track of. It's really hard to manage. And then you kind of have things that go wrong because you have your information security guys will say something like, oh, we've got a new policy that if a firewall rule isn't triggered every quarter or something, then it's considered to be a legacy firewall rule and gets turned off. And then you realize it's like when you have a DR situation, you had a firewall rule that was only going to be used in a disaster recovery. That thing hadn't happened or hadn't been tested, and the rule got disabled, and then something broke, and the failover didn't work because you automatically aged out that firewall. I mean, you have to deal with these things all the time. So I think if you move to a different paradigm in security, it says like I can look at all these flows and I can understand the business logic, and I look at these flows within the enterprise, and I'm really looking for anomalous behavior or stuff that doesn't make sense. I'm not looking to say,
Yeah.
is this IP address going and talking to this IP address, and have I got a rule that says it's allowed to versus, have I got unusual patterns of behavior? And I consciously avoided mentioning, my current employer, IBM, and some of the work we're doing. But I mentioned there was one thing I did want to mention, which was, in our storage division, where we're looking at malware, and we're saying, if you build into the storage platform the ability to detect malware and prevent malware, there's an extra layer of defense. And I was thinking, I was with us storage guys, we were talking about this product they're building, and I was thinking, why don't anybody else ever think of that? It's kind of you've got some code sitting on a hard drive, and it says somebody's just trying to encrypt me, right? And, should they be allowed to do that or not, right? So the network that sees everything should be able to determine what's a normal pattern of behavior, what's an abnormal pattern of behavior. Should I allow this to go ahead? Should somebody in this part of the business ever talk to somebody in this part of it? Should an air conditioning unit, ever talk to a payment system and try and initiate a payment transaction? Well, clearly not if you're a human being. But if you're a network, it's like, hey, are these two subnets allowed to talk to each other? Yeah, fine, I don't care. So
Yeah, I know. Yeah.
I think
There's no
I
consciousness there.
think this is going to be really interesting shift in in that whole kind of security landscape.
That's really, interesting. James, like, the concept that you mentioned is so salient. I want to make sure like we capture it. And that is that will we apply AI to existing infrastructure, or will we basically repeat what we did in the cloud era, where the cloud era they kind of just redefined. What does
Yep.
infrastructure mean? What does it mean to kind of do applications? Will are we basically doing that? Again, so we'll have kind of AI first companies, like we had cloud first, companies, and that there'll be some that will apply, AI to kind of existing infrastructure because you'll be able to get, efficiencies, whether that's, kind of OpEx, reductions, or just increased efficacy, maybe of your security platforms. But maybe that, maybe that's really right, is that like I'm kind of viewing the AI ecosystem as four different layers. On the bottom are the chips. The second is the infrastructure. The third is kind of foundational, which is becoming more and more open sourced and commoditized. And then the fourth layer are the applications. And the applications,
Hmm.
we know about them mostly from kind of the commercial side of it, like Midjourney and ChatGPT and Gronk and and others. But the real AI, enterprise AI applications really haven't hit yet, and maybe that's,
Yeah.
once that layer, and that's where a ton of the money is going to be. The money is really in that layer, and then also the chips and infrastructure. And the chip one is really dominated by NVIDIA, as we know, and the infrastructure is kind of dominated by NVIDIA, also. But there's a broad range of companies in the infrastructure space. Um, that's so salient, that is so insightful.
Yeah.
You're absolutely right. That's probably
And
right.
again,
That's
I think Nick, there's again, there's kind of a paradigm shift that we haven't. I don't think we kind of see it coming. I think how dramatic it's going to be, which is for me is how developer roles are going to change, and
mm,
potentially we're going to see a shift from coding to training, right? So you've seen. I think we're already starting to see these kind of huge improvements in developer productivity by using kind of generative AI to generate computer code. And for
mhm.
enterprises that kind of disallow that or haven't figured out, which tools to use or how to take advantage of that, they're going to be left behind in the dust because
Yeah.
productivity of developers is like orders of magnitude better with Gen AI to kind of write the building blocks of any piece of code they want to write. And
Yeah.
um, but I think there's that's kind of phase one. Phase two is going to be will the role of developers shift more towards the kind of selecting, training, fine tuning AI models? As these kind of pre-built AI services become more prevalent. These enterprise AI applications you talked about, Nick. That
Mm,
it's really about how do you train them on your enterprise data and on your enterprise kind of business process
yeah.
rather than, hey, look, I'm going to go write myself an, I don't know, accounting system or a customer service system or a factory control system or something else. It's more
That
about,
is.
I'm going to
Mm,
take some AI service and I'm going to train and I'm going to train it and let it loose on my enterprise.
yeah. That's so interesting because, like, I, we've all been, uh, all the numbers are kind of pointing that this transition is going to be, multiple times faster than the internet revolution, was, and especially around the developer side of it. So all of a sudden, if the developers do make that shift, which they probably will, and you're seeing this, you're with IBM, like IBM, you freaking had Watson for like what 20 years, so it's like you got like this
I know,
amazing,
but look what's
depth
happened
of
to our share
experience.
price, right? IBM is a major beneficiary of this enterprise, of the AI wave, because I think, and I hope, and it's one of the reasons I joined them. They're seen as a company that has um, the security and privacy and kind of operational capabilities to deliver very, very critical workloads into large enterprises. And there's there's not many of those firms around, and I think they're going to be make major beneficiaries, and we start to see
Yeah,
look at Microsoft, like they're just going gangbusters, right?
it's like crazy. $3 trillion, market cap is like, good for them. It's like, they're delivering a need, in the marketplace. Um, but like if you look at both Microsoft and also IBM, both have deep relationships with the enterprise marketplace. Google, not so much.
Yeah,
Very much more consumer, based company. Amazon, retail, based company that did really great in the cloud infrastructure. We really still waiting for them to kind of like really have a major offering, into the AI space, but really when you think about the big cloud providers, because I think there's probably really what Microsoft and also with IBM is probably benefiting from is that we both companies understand kind of cloud economics and cloud delivery models. Both have deep relationships and trust. Trust is the key word. In the large enterprise, marketplace as well. And
yeah,
so, as we're kind of looking towards this new disruption and this transition, you kind of go to the people that you trust. And the companies that
yeah.
you trust. Obviously,
And
there's
I can
always a
tell
lot
you,
of
Nick. I mean, it's a matter of public record, but if you look at the investments that we're making in IBM Cloud, the capital investments we're making, they are very much driven by a couple of major strategies for us. WatsonX.ai, so our enterprise AI platform, and our push into a kind of a secure cloud for regulated industries. So,
yeah.
we're
Mm.
kind of we're building a business around the fact that we can deliver very complex, very critical workloads in the most trustworthy, private way, but at the same time, building an AI infrastructure that large enterprises, and particularly in the regulated industries, can trust will meet their needs and the regulators' needs for privacy and security and availability. Because this is kind of we're in we're in unknown territory now, right? It's
Yeah.
it's like can you trust your AI provider with your data, or are they going to train their models on it and sell it to someone else? It's there are
Yeah.
I think if you look at the sort of the creative arts, that's a really significant kind of ethical and business and IP problem for them. Is like who
Yeah.
owns artistic content. If you recreate somebody's voice or their look or just the style of their writing or something else. Now, if you're a
Yeah.
large enterprise, do you want models being trained on your own kind of trade secrets that could potentially be sold to someone else? So, I think and I know we're kind of at the
Mm.
end of our short time together to chat, Nick, but this is a fascinating area. I think um,
Yeah.
that is going to shape a lot of the debate around deployment of AI in the enterprise over the next few years.
Yeah. Well, you definitely influenced my thinking, around it. It's I was really kind of focusing more on existing infrastructure and how to make that better. And I'm sure there's a component, to the marketplace going to be there, but now I'm really going to start to like really focus on okay, AI first,
Yeah.
um, because the
If it's
acceleration
not AI
and happen.
enabled, it's too hard to retrofit it. You know what? And you're going to be stuck with that legacy environment that costs you a fortune to maintain. You still need to start thinking about like forklift that stuff out, and instead of employing 1,000 people to go run your computer network, like I've done it some other old jobs of mine.
Yeah.
Do I need just 20 smart people that know how to build AI enabled infrastructures,
Yeah.
and then it runs
Yeah. It's
itself, right?
Well, there is the now the current saying, it's that AI will not take your job away, but it's people with AI skills who will. So it's like,
Yeah.
get get skilled up. So listen, I before we go, I hope you're okay with this. I got to bring this up because like it was such a great story that you shared with me once, and it was like in one of your previous, roles. So like, so just like, so the audience kind of knows is that, you had, domain over this massively large, budget, like, close to about $1 billion a year. and we won't mention like which company. And you were treated, and you used the term like a king of a small country, you know. So it was, and I love that
Yeah, I'm
story.
on the other side now. I'm trying to sell things to people, Nick. It's like, believe me, it's like I don't even get bought a cup of coffee anymore.
I know. Well, that's really what I wanted to like, get your opinion on. It's like that is a very difficult transition to make. It's like, from being a king of a small country, to all of a sudden now people aren't returning your phone calls. It's like that's a humbling, experience. I've experienced that, a couple of times, in my career. So I just wanted to like, ask you, okay, well, are you happier now? Was that transition like a delight? Like, oh my God, thank God I don't have that anymore.
It was, it was.
Or was it just an
Look,
adjustment?
it's an adjustment. It's I work for a great company now, an iconic company in our industry.
Yeah.
But I think it's. I wasn't expecting you to bring it up, but I remember making the comment. But I think it's salient though, because if you look at the way in which large enterprise infrastructure managers are kind of treated, it's
Hmm.
you've got very large budgets, you're very important customers, and the incumbents have got very deep relationships, and it's kind of a scary move to something new, and um, frankly, there's a lot of internal resistance within large enterprises, mainly I think because of risk. Like
Yeah.
put your enterprise at risk by adopting new technology, but the you've got to I think people running large infrastructures have got to kind of sit back sometimes and say, "Hey, look, I've got these long-standing, kind of cozy relationships with these legacy infrastructure companies. Is it the right, is it still the right thing? Can I trust them to move into these new technology areas, or do I need to really start researching and piloting and embracing, some of these new technologies, because I think they're going to come out of entirely new providers, out of new companies, not
Hmm.
necessarily out of some of the legacy infrastructure companies. I think they're too wedded to the past.
Yeah. 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 It's like a great way to kind of turn that
Yeah,
story around into present day and to folks who are still in those roles that you had for so long.
yeah, yeah.
James, this was like
So
so
Nick,
much
it's been
fun.
great to talk. It's been great to talk to you. Lovely to see
Yeah.
you. Hopefully,
Yeah.
hopefully we'll see each other in Dallas. Who knows?
I hope so. Yeah. Yeah.
Yeah,
No, Jim, thanks so much. Everybody, thanks for plugging in. I hope you enjoyed the
yeah. Thank you.
discussion with James. Okay. Thanks,
Okay.
James.